Hi, this is Mrs. McTaggart. In this video we're going to be looking at two little skills that are required in the straight line topic at higher maths. These include the distance and the midpoint formula. So I'm going to take you back to possibly something you might have been shown at National 5 or not. There is a formula that allows you to work out the distance between 2 points. There are two different methods. I find that a lot of time people don't necessarily memorise the formula. So if I take them back to how I might have taught it at National 5, it's a lot easier. And that comes from creating right angle triangles. So imagine this picture wasn't here for a second and it just asked you to find the distance between any 2 points, 1, 2 and 5, 5. All you have to do is do a little sketch and make a right angle triangle like I've got here. The sketch doesn't even need to have the x and the y axes in it at all. What you then do is you try and work out what the sides of the right angle triangle would be. So you're looking to see how far it is between the x coordinates 1 and 5, which is 4. So the triangle would be 4 wide. You look to see how far it would be between the y coordinates 2 and 5, which would be 3. And it creates a little right angle triangle with sides of 3 and 4. And then you would just say, oh well, using Pythagoras, you might recognise this as your 3, 4, 5 triangle. Or you could say, well, Pythagoras says that x squared equals 3 squared plus 4 squared, which is 25. And the square root of that is 5. And that would be how you maybe did it at National 5. You might even go one step further and just go straight to saying, well, x is the square root of 3 squared plus 4 squared, which is kind of what we maybe do at higher to save a wee bit of time. And then that just goes straight to 5 because it's the square root of 25. You might even want to put that line in and say it's the square root of 5. Now, this is my fallback way if you forget the actual distance formula. But what we did here is, I was asking you to find how far it is between the number 1 and 5. A lot of us count up in maths, but what you were really doing is you were doing 5 take away 1. So you were doing your x, your second x coordinate take away your first coordinate. So have a look at this formula here and that might explain where these numbers are coming from. So here is your x coordinate take away your first x coordinate and then square it. Here is your y coordinate take away your second y coordinate and then square it. This is the more mathematical way of doing the distance formula, but at the end of the day, it's worth 1 mark. We're not necessarily looking at your working, we're looking at your answer. So if you forget this formula, think of just doing a quick sketch of the triangle. But we're going to show you using the formula as well. So take you back to what you used to do in that one and label your formula x1, y1, x2, y2. And then we will say that the distance between A and B, well in this case it's r to t. So I would say the distance of r to t equals the square root. And I'll subtract my x's, so I'll do -4 minus 2, which turns into +2, all squared, plus, and then I would subtract my y's, so it'll be -7 minus 5, all squared. And then that would give me -2 squared, plus -12 squared. Which gives me, square them gives me 4 plus 144, which would give me the square root of 148, which you might want to leave as that. You might want to simplify it using surds. You might want to turn it into decimal. It all depends what you're going to be using this for. Once you turn it into decimal, it gives you 12.17 approximately to 2 decimal places. This distance formula is used in the straight line. It's also used again in the circle topic further on in the course. Now, just to prove this worked using the little triangle method again, we could say, right, here's my 2 points. From -2 to 4 is a gap of -2. It really doesn't matter, it's just a gap of 2. From 5 to -7 is a gap of 12. And then just using Pythagoras, you could say, well, it's the square root of 12 squared plus 2 squared, which actually took us to that line there. But because I was just doing it by how far it is from one coordinate to the other, I didn't have the negatives involved. So it's up to you, decide what you prefer, okay? So that is a distance formula. Example 2 wants us to find the midpoint formula. Now you should be familiar with finding the middle of two numbers all the time in maths. If I asked you for the middle of the number 6 and 8, well, you're just going to tell me that the middle number is 7 really easily. But remember when those gaps were a wee bit bigger and I maybe made it like 16 and 28. How did you find the middle then? Well, do you know what? You probably maybe added those two numbers together and halved it and said, well, that was the same as 44. And then half of 44 gave you 22, making your middle number 22. This is how this formula works here. Here is your midpoint formula. So to find the middle, you add your two x coordinates together and half it. You add your two y coordinates together and half it. You're finding the median or the average of the two x coordinates. So let's just do a couple of examples. So for the first one, to find the midpoint here, we simply will call it M for midpoint. And we will do the x coordinates added and then halved. The y coordinates added and then halved. And then that will give us it'll give us positive 2. Let's just rub that out. It'll give us positive 2 over 2. And it will give us 16 over 2. And if you half both those numbers, you end up with 1, 8. So the midpoint of those two coordinates is 1, 8. Same again with the second one. Add the x's, so we've got minus 6, add 6, then half it. Add the y coordinates, 3 plus 4, and then half it. Giving you, well, just 0 over 2, so I'm just going to go straight to 0 there. And then this would give me 7 over 2, which I'm just going to leave as 7 over 2. You could turn that into 3.5 if you wanted, but there's really no need. All right, and that's it. That is how to find your midpoint formula. So this is just a little skill. It is required when you're doing equations of special types of line that you'll see in a later on video. I hope this has helped. Thanks for watching.